and calculates the total pay, and don't forget overtime. So let's bring up Python. Okay, so it said that we had to get hours and rates, so let's read those in from the user. And I'm just going to assume integer hours. If I don't say so in the problem, then you can choose. Pardon? Okay. Somebody's got some feedback going on. Yeah. Rate would definitely have to be money.
You said if you don't specify, we could use either integers or float.
Well, that's true for hours, but for rate, you automatically know that's got to be money because we're dealing with pay. So I would expect you to know that rate should be float. Yeah. Okay, so typically we would go pay equals hours times rate. Okay. But if the person worked overtime, we've got to account for that. So overtime is anything over 40 hours, right? So we're going to have to ask the question, if hours greater than 40, we're going to have to do something special for the calculation. So we would say that if it's 40, we would say the first 40 hours, that at the regular rate, then we would add to it anything over 40. And the rate is time and a half. So you just break down the formula. The first 40 hours are regular rate. Anything over 40 is time and a half. But if he's not over 40, we know it's this. Just plain old hours times rate. And then, of course, we could print that. We'll say pay is $, and we'll say we're going to format pay with 0.2f, and we don't want a space between the $sign and the money. Oh, we save that. Let's run it and see if it works. Hours. We'll do regular pay first, times 10, 400. That's what works. Now, when you have an if statement like this, you're going to have to check for both conditions. We only checked for the condition where the else was done. So now we have to check for something over 40. So we'll say 45 at 10. Okay, very good. So that's the type of thing you'd be looking for that one. Look at number 2. We're going to read into integers and print the larger. Oh, let me get that. Okay, read into integers. Now I just want to know which one's larger. So we're going to start off if well, if number 1 is not larger than number 2, then number 2 must be the larger one, right? Now, I am not looking at the condition if they're equal right now. We'll look at that a little later. So this won't work if the numbers are equal. So 5 and 6, number 2 is larger. Okay. And you can actually put the number there if you'd like. You can say print number 2, comma, is larger. So if I said 5 and 6 again, I'd get 6 is larger. If I run it again, I have 2 conditions. I got to check both of them. So the first one will be larger this time. Number 1 is larger. Okay? Fairly straightforward.
What's the error if you do the same number?
Okay, let's look at that. Yeah, number 1 wasn't greater than number 2, right? So it just does the else. So
Sweet.
we would need, and we're going to do one with another condition on it that checks for that final one. Okay, let's look at number 3. Write a program that reads an integer value and determines if the integer is even or odd, and just prints even or odd. Okay. I'm going to close the shell, come back over to the program. All right, read an integer. Now, this is a math problem, so I have a mathematical operator that I can use on integers that determines if it's even or not, right? So if I come in and say if number mod 2, remember mod gives me a remainder. So if 2 goes into number and there's no remainder, I know it's an even number. So then I know that the remainder must be 0. Okay? If 2 goes into number with no remainder, number's even. And then I can just print even. If it didn't do that, it has to be odd. Okay? That's when these integer arithmetic operators really come in handy.
I have a question.
Oh, yeah.
For the first one, where you have the if and else statement, if else isn't in there, would that still give the right answer since it's saying if it's greater than 40, or you must have else in there?
Well, if you don't have else, what's going to happen if it's 40? This would be 0, and you're right, it probably would give the same answer. Yes, okay. However, coding-wise, that it would be hard to understand for the typical person who knows how this formula works. Yes.
Okay. Thank you.
Unless, of course, they typed in a lower number for hours, then you're in trouble, right?
Right.
Yeah.
Okay.
So it still has some issues, but if they had 0 here, if they had exactly 40, you'd be okay. Yeah. Anything under would be a problem. Okay. Write a program that reads a 2-digit number. That means there's only 2 numbers in this integer and puts each digit on a separate line. So for example, if I typed in 56, I would want it to look like 5 and 6 when it prints out. And I tell you, that's a math problem. So let's read in the 2 numbers. Be specific. Enter 2-digit number. That way the user knows what to do. All right. So what I want to do is I want to split this number into 2 pieces. Well, this is an integer arithmetic problem, and I already know part of the problem because I already know how to use a mod to get a remainder. So for example, if I divided odd, there's nothing remaining, right? Because 10 goes into 10 once. So the answer to this basically would be 0. Well, look at that. That's that second digit right there, 0. Okay. If I were to do integer arithmetic, what does this tell me? This tells me that 10 goes into 10 1, and that's the exact first digit. So all I have to do is use those particular operations. So I'm going to say first digit equals number 1 mod 10. I mean, divide 10. Second digit equals 1 mod 10. Looking at how many times it will go into the number and what is left over from the number. And that basically splits it up. First digit, and then I can print. So if I type in 56, I get 56. Run it again, I'll type in, I don't know, 25. And that will split it up. If you have more digits that you wanted to split, like 3 or whatever, you just have to do this some more times. Okay? And eventually we'll look into something like that. All right? All right. The bottom line of this worksheet, you want to learn how to use if statements. Okay? This is the only one that didn't use an if statement because we were trying our luck at integer arithmetic. Okay? Okay, so we have I want a new one. Okay. We basically are if and if else. Remember on an if, the condition has to be true to get performed. If X will do something, but if that's not true, if X is not true, we'll might have an else, and print something else or do something else. Okay. If is only done if it's true. So let's look at a problem where I'm going to read in the grade and we're going to determine if we are an A, B, or C. So I'm going to read in a grade. We'll just assume they're integer grades. And I want to just print A, B, or C. And it's the usual scale. So if grade greater than or equal to 90, print an A. And let's try it this way first. If grade greater than or equal to 80, I'll print a B. Grade greater than or equal to 70, I'll print a C. All will do. Okay, so if I save that and run it, if I type in 75, I get a C. That's what I would expect. If I type in 85, oh, I get a B and a C. And if I type in 95, I get an A, B, and a C. That's because all of these are separate if statements. And each one, when I typed in 95, each one of these was true. It was greater than 90, it was greater than 80, and it was greater than 70. When I typed in 85, it wasn't greater than 90, but it was greater than 80 and greater than 70. And then when I typed in 75, it wasn't greater than this, it wasn't greater than that, but it was greater than this. So obviously a solution like this won't cover all the bases, because if they made an A, they'll get a B and a C with it. We need to fix that. And in fact, we really only want one of these to be true at a time. When you want that, you can use an elif. Okay. This way, Python looks at it and goes, is the grade greater than 90? No. Is it greater than 80? No. Is it greater than 70 for the first one? Yes. So it prints C. When I type in 85, it goes, is it greater than 90? No. Is it greater than 80? Yes. It prints B and falls out. Remember, in an if-elif, only one can be true. And the first one it finds that's true, it does that thing and then stops. Right? So if I run this now and I type in 90, I get just A. Okay? If I type in 85, I get just B. So while I have 3 if statements, I have now made it so that only one of them can be true, and only that one will be executed. Okay? So it depends on what you're trying to solve, what type of if statement you'll use, and we're going to write it in another way in just a minute. But it does depend on what you're trying to do and how you want to write it, okay? There's another way to do this. Remember, we've done our logical operators. Was greater than, less than, greater than, equals, not equals, all right? And those are the ones we use here when we're asking questions like this. Okay? We have another kind of operator. Those are, I'm sorry, these were relational operators, yeah. We have another kind of operator, and that one is logical. Those are simply words and or and not. Let's see how those work. We're going to rewrite this, but this time we're going to bracket what an A can be, what a B can be, and what a C can be. So for example, once I read it, and I'm going to say if grade greater than 89 and grade less than, that's where an A falls, right? Between 90 and 100. Then I know I can print A. Now I have bracketed it, so there's no problem if I have multiple if statements now. Okay. So notice that I used a logical operator amidst all these relationships I'm checking on. And all this logical operator says is, if this is true and this is true, then I know it's got to be an A. So if he's greater than 89 and less than 101, so in other words, he's between 90 and 100, then he's an A. If he's greater than 79 and less than 90, he's got to be a B. Now you can do this a couple of ways. I could have said greater than equal to 90. Greater than equal to 90 is the same as greater than 89, right? And I could have done grade less than or equal to 100. Whichever works for you, okay? Whichever you understand the best. It just depends if you want to be greater or greater than equal to. All right. Let me comment this out. See if we got our thing going here. So if I type in 75, I didn't. Oh, wait a minute. Where am I? Didn't see anything. Well, that's not right. What did we miss? We're not missing a print statement. I ran it, so we entered the grade. If grade, it should have been right. Oh. greater than. Yeah, I just put the wrong symbol in there. Okay. However, when I had that, all right, it knew it wasn't these two, so it came down here. All right, the grade was not less than 69, so it was never going to print a C. Okay, so I just had the wrong symbol. A C falls between 70 and 80. Let's try it again. All right, so if I run it again, and this time I type in 95, I get an A. We'll run it one more time, and we'll do a B, 83, and get a B. All right. As I said, when you have these multiple if statements, you're going to have to run the code at least that many times and check to make sure each one of them works. Okay. The only thing we didn't take care of was if they were going to make an F greater than 70. We'll just put an F there. Okay. We could have done that up here with just an else. All of these would have worked just fine. It depends on whether you want to use logical operators or not. Remember, an AND says both of these have to be true before it will print an A or a B or so forth. Okay? And OR, let's set X equal 2 and Y equal 3. And then we could say if X equal to or Y equals 4. Okay, we'll just print yes. So what's going to happen is the OR says it's going to look at both separately. So X is 2, so that's true. But Y is not 4. Y is not 4, it's 3, right? But it said, but this one was true, so I can go on and still print yes because of the OR. One of them has to be true to get this done. OR says one of these has to evaluate to true. Okay? And said both of them had to be true. Okay? Both of them had to be true. Now, he's got a little table in the book that also describes all this as well. So just make sure that you look at these and get familiar with this. The relational operators and the logical operators are basically the same for every programming language. They might have a little different syntax. They might have a symbol instead of the word, but they're all the same and they work the same. All right. So I bring this up because if you were to look at homework 1 and you look at the 4th problem, this is a bracketing problem, like we were doing here, where you had this and this. We're asking if the salary falls over 50, but less than 75, right? Over 75, but less than 100, or up to 100, less than $100,001 or something. Over 100, less than equal to 250. So number 4 would use this technique to solve that problem because you're looking at ranges for each of those. Okay, and so you'd have like 1, 2, 3, 4, 5, 6 or so, yeah, on how to do that. All right. So you will use logical operators to solve number 4. This problem is nothing more than reading in the income and a set of if statements. All right. And there's several ways you could do it. If you wanted to use elif, you could. All right. I don't think I specified, so any of those options are okay. But it is a bracketing problem. Okay. So make sure you look at that. See if you can apply that to that. Notice up here on problem 3, I was asking if something was divisible by 2 or by 3. When we did the worksheet problem, where was it? Oh, there it is. When we did the worksheet problem, and I was looking for something divisible by 2, this problem tells you if something's divisible by 2. All right? And if I want to know if something's divisible by 3, I just, okay, fine. I'll just put in 3 and see if it's divisible by 3. All right? So you have enough information to do all of the homework. I mean, you need to practice some, obviously, but you have everything syntax-wise that you need to solve the homework. Okay? There. Because we've already done 1 and 2, basically. You have a sample for number 3, and you have a sample for number 4 for those. All right. I would encourage you to get as far as you can on the homework this weekend. We've already done 1 and 2, so you're at least 50 to 70% done. Get as far as you can this weekend so we can look at it next week. You have 2 lab opportunities next week to get help in the lab with your homework. Next week, we're not going to cover any new material. We're just going to repeat some of these and do extra problems. I'll answer questions about the homework, things like that. This weekend, I'll put up a worksheet for the first quiz. And then next Thursday, that's what we'll do in classes. We'll go over that quiz worksheet. And then that's homework day. Thursday, your homework is due. And then the next Tuesday, the 9th, is the first quiz. But we will have gone over the worksheet for the quiz and all of this. So, and you have all of these worksheets as well. And you have the textbook. Don't forget, he's got all those questions at the end of each chapter and all the checkpoints as well. So next week, we're just going to work all samples and work on our homework, okay? And you have basically 4 opportunities to hit either the GTA or me for help on all of this. All right. If you've already done it and turned it in, and there have been a few, make sure that you've checked all these conditions and you're not doing things that we haven't covered in class, okay? Because you won't get full credit then. Does anybody have any questions in general about the homework and turning it in or anything? Okay.
I had a
question
on problem number 4, but this is kind of me personally. So I had like a if income statement, but then I thought it was like tax equals income times the number 1%. So
okay, I'm not quite sure what you're saying.
so it's like my if statement is if income is less than 50,000 for problem number 1, and then semicolon tax equals brackets income times 0.01, and then print the format that we use. But then when it comes later in it, it kind of messes up. So.
Oh, okay. So I see what you want to be looking at is you're reading into income. Okay. And your first if statement is correct. You had if income less than equal to 50,000. And then you said tax equals 0.01 times income, right? Yeah. So your first if statement is correct. Don't print here. Don't print there. Do all of the ifs and then print tax.
Okay. But at each. Okay.
Then when you're done,
that makes sense. Thank you. That's exactly what I was looking for. Thank you.
Okay. And then just print tax. Yeah. Now don't forget though that when you're looking on the next one, for example, LF income greater than 50,000 and income less than equal to 75. If you're looking at something like that, tax is what? How do you calculate that one now? Well, the first 50,000 is 0.01. Oops. The first 50,000 is 0.01 plus it's 2% of anything over 50,000. So 0.02 times whatever's over 50,000. Okay. Similar to the calculate the pay rate type of thing. I'm down to the next LF. Okay. And might have a parentheses or something. Oh, it wants another one there. That's fine. Yeah. Okay. And you'll have your other LFs. And as you go, this calculation gets a little longer because then the next one has an extra condition to add to it as well. Yeah. So that's the start of it. Okay. Then when you're all done, you can print it, format it, all that kind of stuff. Okay. Okay.
Thanks. I do
No
appreciate
So
that.
make sure everybody, y'all look at that. Make sure you kind of understand what's going on and everything. And either I or the TA can help you. Oh, before I think about it, I had to cancel the office hours today. I sent you out an email. I got called in for my vaccine, and they want me at 11 o'clock, so I can't have office hours. So they told me I'd have to wait in line for 2 hours, but I'll go and try. We'll see what happens. I don't know if I want to wait that long. But anyway, so you can email me with questions later today, or we have labs next week, and we'll work in class on homeworks as well. Okay. Okay. So now let's look at, let me see where we were. Oh, let's just do a new one. All right, we had done relational operators. We've done logical operators. There's one other variable type that we're going to be using throughout the semester. It's a real easy one. It's called Boolean variable. So you can set a variable like X to true or Y to false. Okay. If you're a Boolean variable, you can only have two values, true or false. Notice that it starts with capital letter. Okay. So now I could come in and I could say if X okay, oops. Yeah. It prints yes because X is true. Remember when I was doing things like X equal 2, it was just seeing if X was 2 and then it set that to true. That's all it's doing. Now I'm just skipping over a calculation and just saying, hey, if X, then print. All right. Now, if Y, will it print? I'll just say Y. Okay, will it print Y? No, because why? Well, Y is not true. Y is false. Remember, an if can only be done if it's true. Only be done if it's true. All right. I bring this up because this will be quite useful, okay, on your third problem. That asks if a number is divisible by 2 and 3, or 2 and 3, or only one of them. Well, we already know to figure out how the number is divisible, right? That was the one where we did all of the, oops, I can't find it. It is here somewhere. That one. Nope, apparently not. I got too many open now. Ah, there it is. We did this one to find out if it was divisible by 2. So what you could potentially do is something like, where's the one I was working on? Here we go. You could come in here, you read your two numbers, okay, and then you could say, if number 1 mod 2 0. That right there will ask if it's divisible by 2, right? You could come in and you could set a variable by 2 true. You could come in and you could ask the question again if number, it's just one number. I don't know why I said 2. Read in the number. Yeah. If number 1 mod 3 equals 0, then I know it's divisible by 3, right? And I could say by 3 is true. Okay. Now this isn't the whole thing. You have to think a little bit. Because if this isn't true, what do you set by to be? Well, you need to set it to false. So you'd have to fix this a little bit to handle true or false. But then once you knew all of that, you could come in and say something like, if by 2 and by 3, you'd know that it was divisible by both. Another one might be if by 2 and not by 3, okay? Try that. If by 2 and not by 3. Okay. Now, not basically says the opposite. If by 3 is false, this sets it to true, so it will turn this on. Now, this is a little tricky, okay? You got to think about this one. What I would do is I'd do the easy ones first and get those working, and then I'd worry about this one near the end, because there's 3 logical operators, and, or, and not. Not just turns this the other. Whatever it is, it turns it the opposite. If it's true, it turns it false. If it's false, it turns it true. So you could use some combination of ands and nots to get the answers to number 2, okay? But the first thing I would do is just set it up, read it in, and check out whether these are true or false. Then you can set up your if statements to determine the answers to the questions that it's asking and everything, all right? So 3 and 4 are just a little bit, not tricky, but a little bit advanced. You just have to pay attention. They're not long. You just have to pay attention to what you're trying to do, okay? I urge you to take a stab at those so we can look at those more next week, okay? And then you can ask particular questions. And just because I do it a certain way doesn't mean that's the way you're going to do it. You're going to have to still use these types of things, but you might just approach it a different way. All right, not a problem. All right. Okay, let's look at our practice code for this week. We wanted, on page 151, we wanted 1 and 3. 1 and 3. So day of the week. I want to write a program that I asked for the number 1 through 7, and I print Monday, Tuesday, Wednesday, Thursday. Okay, all right, so let's look at that. All right, so day equals, now it's going to be an integer because there's no half a days for numbers. Per day, 1 through 7. Let them know what it is you need them to enter, or they might, if I'd have just said enter day, they might enter the actual day, Monday or Tuesday or something. Okay, so I've got that, and I'm just going to if day equals 1. Equals 2. Long. Now, if he's not 1 through 7, then he must enter a number 1 through 7. Okay. So that's pretty easy. All right. Now, I could have done this with that many if statements as well. It didn't have to be elif, because each one of these is a specific day. If it's day 1, print this. If it's day 2, print this. So there wouldn't have been any conflicts with using a set of if statements here. The only one at the end would have been tough, though, right? Because there's no else like that. So if you did if statements, Last if statement would have to be what? If A, and you want to make sure that it is not 1 through 7. And there's a couple of ways to do that. So let's try this one. If day greater than equal to 1 and day less than 8. All right, now that's true, right? That's what you're looking for. I really want the opposite of that, right? Oh, not that. All right. See if we got the syntax correct. So, let me just get a new. Okay, so let me enter an 8. Okay, it didn't like 8 because that's not, gosh, where is it? There it is. Because that's not what I asked for, right? So I did separate if statements, and then I did a separate if statement for if it didn't match any of those numbers. And the way I did that was I was looking for day being between 1 and 8. If that turned out to be false, which was true because I typed in 8, that turned out to be false. In order to get this if statement to print, I had to say the opposite of false. Now you have to think about these a little bit, okay? If this turned out to be false, which it was, in order to get this print to work, I had to make it true. That's what the not did. It turned that false into a true so it would work and run that statement. All right. You got to think about those a little bit.
Is there a day, like a way to make string visible? So it's like if somebody starts their day on, let's say Sunday, they might enter that as day 1 instead of day 2.
Oh, okay. I see. Yeah. Well, the best thing you should do is say up here, day 1 is Monday, so they'll know. Yeah. A lot of people, you're right. A real week starts on a Sunday. Yeah. It doesn't start on a Monday. He just assumed everybody thought it was a Monday. Yeah. That would be much more complicated to have to figure out if we just didn't tell them 1 is Monday. Yeah. Good question. It's just tougher to do. Absolutely.
So will you just put it like day 1 and then parentheses and then say Sunday in there?
You could. Yeah.
Okay.
Yeah. Oh no. Okay. Then you'd have to change these,
Monday.
Of course. Yeah. Yeah. And that's a good point for a couple of reasons. Sometimes he doesn't write it the same way as we think about it as he writes it in the book. And just different people think the day starts on the week starts on a different day. So you should be very specific with your user like that so they'll know what you're doing. Yes, very good. All right. Then we had age classifier. Write a program that asks the user's age and display a message. So if he's less than 1, he's an infant. If he's between 1 and 13, a child, and so forth. Okay. So that should be fairly easy. Let's go look at that. Yep. Here we go. Just comment that out.
Professor, how do you separate the problems? Like, let's say like we're done with number 1 and we're doing number 2, and then when we run it, like as soon as I run it, all the same problem that it just comes in the same format. Like I just want a partition or something.
When it runs?
Yeah.
Okay, so I'm not exactly sure what you're asking. Here I'm commenting out the first problem so it doesn't run again.
No, well, I was talking about the homework. Like, let's say that I did problem 1, problem 2, problem 3, and problem 4.
And they're all separated by one comment that says problem 1, problem 2, 3, 4. And I'm going to run them all, one right after the other. So I don't want them commented out or anything. Is that what you're asking?
Yeah, well, yeah, all my problems, it just runs like all at once. Like, you know what I'm saying?
That is correct. That's exactly what I want when I run the problem to grade it. But if you're working on it and you only want one to run at a time, you can comment it out like this.
Yeah, and then for my name, like whenever I run it, like I can't see my name on it though.
Oh, well, it won't run your name. Remember, anything in a comment is ignored, okay? If you put a comment with your name, it's ignored, and Python doesn't pay any attention to it, so it doesn't print it out.
Oh, okay. Yeah, I was just wondering if it was just me or if I was
No,
doing
it's
it
not
wrong
just
or
you.
something.
Yeah. I want the name here for me when I look at your code,
Oh,
but
okay.
it won't show up when I run it.
Yeah, and then whenever I run the program, like it's just gonna run in the black screen, right? I mean, it's not.
No, 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 no. No, you need to run it like I'm doing here in idle.
Well, this is how I do, but after I save it and open it again, like it just comes in the black screen.
Well, but you're double clicking on it, aren't you?
Yeah.
Don't do that. Don't do that. The double click tells Python to open it up in the command window of Windows, and that's not what you want.
Oh, I gotta run with like open with and then the DLE or whatever it is.
Yeah, that's right. You want to run it through idle, because that's exactly what I'm going to do when I grade it.
Oh, okay, sure.
Okay. The problem with running it in the command window is it runs and immediately quits and closes the window.
Yeah, it just closes
So you can't
automatically.
see
I mean,
anything.
yeah.
Yes,
And
that's
I
what
was just
I'm doing.
worried because like everything I did correctly, but I think I was like missing out on something. So
No, no, just don't run it in there. Always run it like I'm running it here.
yeah,
And
sure.
then you'll
Thank
know.
you.
Okay. All right, so we're going to enter age. And the first one was if age less than 1. Is that less than or equal to? Oops. Less than or equal to. Here it is. Equal to 1 year old or less. So that's equal to. Okay. Doggone it. There. Infinite. If. All right. And then we'll have age greater than 1 and age less than 13. Print. Greater than, what was it? Age greater than 13. Age. Now let me check. Did he say greater than, equal to, whatever? All right. He's less than 13. Here he's at least 13. Okay, so that's an equal. Okay, so he's, let me see, less than he's greater than or equal to 13 and less than 20. All right, he's a teenager. And then else, he's an adult. Okay. Yeah. So you'll notice this is similar to the homework where I have bracketing that you need to do, even though it's a little fancier bracketing with bigger numbers. But yes, it's basically the same for that. Okay. What else was on there? So I think those were the only practice ones. What was the algorithm workbench? 1, 2, 5, 6. Okay. So if I come here to the algorithm workbench in the book, and that's on 151, 1, 2, 5, 6, can't remember. 1, 2, 5, 6, okay. 1, write an if statement that assigns 20 to y and assigns 40 to z if the variable is greater than x. Now notice when he writes these, the if is always at the end, and that's where you should start. So it's really if, what did he say? X is greater than 100. If x is greater than 100, I want y to be 20, z to be 40. Y equals 20, z equals 40. Okay. Look at 2. If A is less than 10. I want B to be 0, C to be 1. B equals 0, C equals 1. Add. And then it said 1, 2, 5, 6. 1, 2, 5, 6. Nested decision structures. Okay, so the first thing I need to do is if amount is greater than 10 and amount is less than 20. All right, so that's an and, because you can tell that right there. That's exactly what he says. If amount is greater than 10 and amount 2 is less than 100. Okay. 1 greater than 10 and that's the first one. I need to figure out which is greater, 1 or 2. Very similar to the problem on the worksheet, right? So if I know it falls in there, then I can ask if what? He wants to know. Oh, the greater of. Oh, okay. If amount 1 greater than amount 2, greater than amount 1, print amount 2 is larger. Now here we'll come in and we'll say else they are equal. Just want to make sure you practice all these if statements. So then it was 5 and then 6. Display speed is normal if the speed, oh, is in a range. Oh, okay, 24 to 56. All right. So we'll say speed's been ready in if speed and speed something like that. Okay, so now don't forget that when you're doing these, especially with logical operators, and you have condition on the left and condition on the right, you have to repeat the variable. You need to say if speed is this and speed is that. You can't say if speed this and that. You cannot do that. You've got to put in the variable name. Okay. All right. And so those are the problems from Canvas then, plus the worksheet that we've already done. Okay. Any questions about those? All right. Okay. I'm going to have to let you go at this stage because I've got to hop in the car and go down and wait in line for 2 hours. So if you have anything you need, let me know. Any questions right now?
I do have a question, Professor. So all the grade is from the homework and the quizzes only, right?
That's right.
Yeah, just making sure. Thank you.
Okay, not a problem. Oh, and don't forget to do the practice quiz. If you're not used to lockdown browser and the webcam, you got till Sunday night to practice on that. You can take as many times as you want. Doesn't count or anything. It's just practice. I'll post everything for the quiz this weekend, and then we'll go over it next week in class as well. All right. Your goal is to work on the homework and work on these samples that we did, just so you can get used to working with some Python. Okay. Any other questions? Okay, then I will see y'all then on Tuesday, I guess. But send me email if you have questions.
All right. Let us know about the shot.
Yeah. I'm not looking forward to it. I don't like shots by any means. And I'm hoping that if I stand there 2 hours, they really will have it when I get in, you know? Sometimes running out.
Do you know the name of the shot you're getting? Is it like Pfizer
Moderna.
or? Oh,
Moderna.
Moderna. All
So I'll
right.
have to have another one. I don't want to do that either. Yeah. But hopefully it'll be okay. All right, guys. Y'all have a good weekend.
All right. Hopefully you're gonna get a candy after the shot, huh?
Yeah, that's get a lollipop. All right.
All right. Thank you.
Bye.